Hello, Megan.
Mhm.
Today, we're going to be interviewing you for the software developer position. I'm Matthew de Guzman. I'll be your interviewer for today. And to start things off, I just want to ask how you're doing. How you feeling?
I'm good. I'm a
You
little
good?
nervous.
A little nervous?
Yeah, but I'm really excited to be
Okay.
applying for the job position, and I actually think I'll be a pretty good fit.
Okay.
So I'm nervous, but I'm excited for the job
All
interview.
right.
So,
Awesome. That's
mhm.
great to hear. And don't be too nervous. We're all rooting for you to succeed. So I think you'll do great. All right. So, first question I want to ask is I want to get to know you. So, what's your story? How'd you end up here? And why do you want to be here?
So, I'll start with attending university since that was pretty major for me. I grew up with a single mom, so we didn't have many resources, I would say. And the one thing I really embodied, I think, was perseverance. So even though we didn't have a lot of resources, my mom was working a job during Monday through Friday and then another job part time Saturday and Sunday. So when I was left to my own devices, I'd study or, I'd have my hobbies as well. But even though we didn't have many resources, I still had to persevere in school. So I was on my own a little bit. I was a lot more independent, I feel like, and I wasn't exactly able to be coddled, unfortunately. I kind of wish I was. um, but the fact that I think I worked hard enough in high school on my own made me feel proud of my family since I'm first gen.
Hmm.
So my family didn't exactly, education wasn't a priority. So when I made it into university, and not just that, but with the scholarships, I was taking classes for free. That's been major. And then I decided I liked computer science a lot. So then I went into computer science. Then I took my first like math class, which was discrete, not like
Hmm.
calculus or anything. But I did like calculus, but that
Okay.
wasn't like my sign to go into math.
Hmm.
Um, my sign was discrete structures. So
I see.
when I took that, I realized I really liked math and I wanted to do more of that stuff, which is probably considered late for picking a major, but that was like my freshman year. So I decided to pursue math as well, but I couldn't choose. So I just kind of did math classes until I realized I could double major.
Hmm.
Um, and now I realize that software development is a pretty good like branch between computer science and math. So that all of that led here to doing this job interview.
Oh,
So
wow.
here I am.
Well, I'm glad we could meet, and it's very inspiring and great story. So I'm glad we have the opportunity today. So, another question, just why do you want to work here specifically at Gator Nation?
So to be a software developer, first of all, it's Gator Nation.
Oh, of
Here
course.
at the University of Florida, or Gators, first of all, Gators are pretty popular in Florida, apex predators. And I would say to work at the company is to kind of be at the top. We'd work hard. I don't want to say just like a Gator, but it is just like a Gator. So I want to work for a company that really values me as an employee and a company where I can challenge myself and be challenged by others, all while being creative.
I see. Okay. Well, another thing here at the Gator Nation is teamwork. We work a lot in teams, and if it doesn't work, then our company as a whole just doesn't succeed. So I'd like to know how you work in teams, and when was the last time you worked, and how did it go, like within a team?
So I think naturally, as human beings, a lot of us flourish in teams. And I have worked in teams throughout classes just this semester. But the largest amount of teamwork I had to do was being a TA. So there was this organization called Girls Who Code, and I participated with them during high school, actually. They got me into computer science. Um, so I got the position of lead TA, even though I wouldn't say I was fully qualified, but they believed in me,
Wow.
thankfully. And there were other TAs and there was an instructor. So the lead TA had to put in a lot of work, but I organized enough meetings every day before class. We had 60 to 70 students online. So we would meet before class and then after class to kind of reflect or do better on what we did during class. So when I proposed those meetings, not everybody was fully into it, But it ended up being really, really helpful because students would come to us with questions. We would have office hours after that. And then the TAs and the staff would need to meet all after that and then go over everything, review the day kind of. And that really helped for preparing for the next day. So I think in that sense, even though we all have our own like individual responsibilities, we're all kind of independent. If we work together, we could make the experience a lot better for others who are kind of relying on our work.
I see. So you have this sort of natural tendency to be a leader and to bring people together, then you'd say.
Right.
Awesome. Well, I think that wraps up the behavioral portion of it, and we can get on with the technical part.
All right, cool.
Sounds good. All right, Megan. Now we're going to continue the technical portion of this interview. So I want to ask you, are you familiar with postfix notation?
Yes, I am.
All right. Well, just in case you aren't, I'll freshen up your memory. So typically we write math equations like 1 plus 2, right?
Right.
And we would just call that infix notation. Well, in
right.
postfix notation, we write the operator after the operand. So we would write this in a postfix, right? Let me just say postfix. We would write this as 1, 2, plus. Now these would evaluate to the same expression, but they're just written differently, right? So in this problem that I'm giving you, you're given a list of, this list is going to represent a postfix expression. And I want you to evaluate it and give me the expected value. So let's say we're given a list, right? And this is going to be a list of strings. So let's say we have 2, 3, and then we have the plus, and then after that we have, let's say, another 2, and then we have a multiplication sign after that. And this is our entire list. So we would first do this. So we would see 2, 3, and then we would say that's 5. And then we have this 2 and this multiplication, and this would just be evaluated to 10. So that's how this entire expression should be evaluated. And so we're just going to give you a whole list, and we need you to figure out what its value is.
Okay, I see. All right, so it's one operation at a time, depending on where the actual operator is located, which will be after the actual 2 numbers. Right?
Yes.
Okay. And will they always be, the list of numbers, will they always be valid, as in I will actually get a result from them?
Yes.
Okay.
Oh yes, I'd like to also clarify that the operands that are, or the operands that are in here, they're going to be plus, minus, multiplication, division, as well as the modulo operator. And all of these are always going to be valid operations, so there's never going to be like a divide by 0 in here, so you don't necessarily have to worry about that.
Okay. All right. So I see that I'm going to always want kind of the most recent numbers in the list, and these are strings.
Yes.
So I definitely want to convert them to integers.
Mm-hmm.
And since I want the most recent elements or strings that I'm going to convert to integers, I'm going to use a stack for that reason, so kind of like a container. So in this case, if I started with a stack, let's say my stack looked like this, and my list was 2, so I'd push 2 in the stack, and then I would push 3. But I can stop at that addition symbol, and then I can pop the 3 out, like this, and I can pop the 2 out, and I can kind of evaluate it. And since I have to keep going with further operations, I want to use this 5 or reuse it, so I push it back in the stack for that reason, and then continue until I identify another operator, because then I want to use the numbers in the stack to do the operation, right?
Okay. Yeah, that sounds good.
Okay, so I'm definitely using a stack. And I know in some languages, they have functions where you can return, or you can convert a string to an integer.
Yep.
But in that case, I'm just going to use C++, because I am familiar with stoy, string to int. So, but first I want a function.
Yep.
And I want to return the result that I get since all of my expressions will be valid.
Mm-hmm.
So I'm going to start here. I'm going to say int, and then I will say eval expression. And you said I will have a list, right?
Yep. So however you want to express it, vector, array, either matters.
Okay, so I'll chop this off just so I have some more space over there. So vector and strings.
Yep.
Okay. How about a name?
Yeah, you can name it whatever you'd like.
Okay, I would just name it numbers. Okay.
All right.
So I have my little brackets here. Okay. So we agreed on creating a stack. And in C++, you create a stack like this. And even though I have a vector of strings, I still want to convert it to integers. So I'm going to have my stack stk. I also need a result variable of type int since I want to return that. And if I'm going to have operators, and that will be a yes since each expression will be valid and the vector of strings or the entire expression will be valid, then I need 2 operands for each operator. Okay. So these are my variables. I have my function, I have a stack, I have int result, int a, and int b. Okay, and I'm going to move this over here. So I'm thinking the logic behind this could be if I have a vector of strings, so let's say I have that 2 and 3. If I have that 2, I want to push it in the stack like what we did before. But if I have the actual operator, then I want to stop there and get that 2 and 3. So assuming that it's valid, I can actually get the most recent elements or the most recent numbers from the stack because an operator isn't going to be pushed to the stack. So instead of an if statement, I'm going to have a for each loop.
Okay.
I'm kind of running out of space here. So how about I do it up here?
Yeah, you can just write it down and then just continue over here if you'd like.
Write it over here?
Yeah, if you run out of space, then you can just continue here.
Okay.
Yeah.
So I'm doing a for each loop just out of preference. They're a lot shorter and I like how it looks. So I'm going to do for auto, I will do x in nums. Okay. I have my for each loop and I'm going through my vector of strings named nums, and if I reach an operator, so if x is equal to, we'll start with the addition symbol, then I want to get the most recent numbers and use the addition symbol to complete the operation. So for my stack, I'm going to do, I'm going to set it equal to a for my first number. So a is equal to stk dot top. And then I'm going to pop from my stack. And I'm going to do the same thing. Going to push this bracket kind of down. Do the same thing for b since I need 2 numbers to do the operation. So I'm going to do b stk dot top and then pop that off because they have been used. Okay. So the assumption or the promise, if they're all valid, is that I have 2 numbers if I have an operator. So given that, I want to continue checking for all of the operators, and there are 5. So is it okay if, since this will pretty much be the same for each operator, this if statement. If I do this, instead of writing all of it,
Yeah.
kind of like maybe multiplied by 5. So I will do an if statement up here.
Okay.
I'll do if x is equal to minus. And I'm going to call this body or logic.
Oh, just one question.
Mhm.
And after you pop them off, are you going to do anything with them, or?
Yes, I'm going to
Oh,
do something
okay,
with
I
them.
see.
Yes, for sure. Sorry, I completely forgot about the actual operation. But that's why I have my result variable. So this will be my logic. And for the result variable, I'll make these kind of smaller. But that's a priority. So result will equal to, we will do a plus b. But since some of my operations are like subtraction, that will be non-commutative.
Mm-hmm.
So I'm actually going to do b plus a, because that's what I'm going to do if I reach my if statement involving subtraction. And I just want to keep it consistent, because in subtraction I will do b minus a, so I'm going to keep the operations with b first. And I can also change this a to b and keep it as a plus b, because the top element of the stack needs to be the second number when I actually do the operation. Okay. So I called that logic, and what I'm going to do is I'm just going to write logic, kind of like a variable substitution.
Yeah.
And I'm going to just do the operation for each of these. I'm going to do result is equal to, in this case, it would be b minus a. Okay, got the little semicolon, but it doesn't really matter unless we are running it, which we can't. And I'm going to do if x is multiplication, then same logic. And by logic, it's taking the first two numbers from the top of the stack, and then we are doing the actual operation, which is b times a. And I'm just going to repeat this. If x is equal to division, I'm going to do logic, and then I'm going to do the same thing, where result is equal to b divided by a.
Yep.
And lastly, and thankfully, is x is equal to modulo, so just the remainder. Same logic, I will need two numbers for the operation for the operator that I find, and I'm going to store that in my result. I'm going to do b modulo a. And these if statements, they do need brackets, so, but do I need to?
No, you're fine. I understand it, so.
Okay. So far, I have my variables in my stack. If I find an operation, it assumes that there are two numbers on the stack to complete the operation, if I find an operator.
Okay.
So that's the logic here. And then I do the operation, store it in my result variable. But if I have a number, that's going to be my final else. So instead of a bunch of ifs, I'm going to have else if, and else if. And for my final else, can I do it here?
Sure.
Okay.
Or you can write it here.
Yeah. Okay, for my final else, that will be if I have a number. And in that case, I'm going to do the same thing, string to int. And my for each loop is x. And once I have that, I want to, let's say, push that number, and I want to continue pushing the result anyway to my stack. And I also want to return, this will be the end of my function, but return the result, which will be the last element or the top element of the stack.
Okay.
And I'm just avoiding writing the stack.top because that will require me to access the stack one last time. And I'd rather just return the result because I believe that can help in the runtime. So essentially, I have something like 2, 3 plus 2 and then times. So my 2, I'm going through the vector of strings, and it's not an operator, but it goes to this else statement, and result is going to equal 2. And then result gets pushed to the stack. So currently, my stack has 2. Okay. And then I go again, which is 3. Result is equal to 3, and it gets pushed in the stack. But then I have an addition symbol, so that will be over here. So A will equal to 3, and B will equal to 2, and I take those off the stack. And then I perform my operation, so result is now equal to B plus A, which is 2 plus 3, which is 5. And you can see at the very end, I'm constantly pushing my result into the stack in case I have to use it again in the future, in case I run into another operator. So I'm going to have 5 over here. Then I'm going to run into 2, which isn't an operator. So I'm going to go here, and I'm going to push 2 into the stack right here. Lastly, I have a multiplication symbol, so that will go over here. And then I will assign, well, B will now be, what is it, 2. And, oh no, actually A will be 2. And B will be 5. Take those off, and then I do 5 times 2, which is 10. So my result becomes 10, and that's pushed onto the stack. So I just have 10 up here in case I wanted to actually return the top of the stack. But my result is already equal to 10, so I'm just going to return 10.
I see.
Okay.
All right.
Right.
Yeah.
This took up quite a bit of space, and to go over that, you can see the real amount of space wasn't just my large handwriting, but this block of code right here, the logic, which is repeated here, 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 and here. And I think that could be a problem because even though the time complexity for this solution is going to be O of n, we'll do O of n, where n is the size of the vector of strings that's given to us because we're going throughout it. Best case is if we just have a number and we just access that. Worst case is O of n. But again, this logic, it won't change the time complexity if we kind of condense it and take it out of the if statements, which we of course can. So if I wanted to, I can move this out of here. But if I did that, I might run into the scenario where I pop from an empty stack. Mm-hmm. And I don't want to do that. So outside of my for each loop, I want something kind of like, and I'll do this as a comment in case I were to move this out. I want something like stk.push, and then I would do string to int and nums at 0. So I have at least one element in there, and then there would be like that. Okay. I can do some more operations, but I kind of ran out of space.
Yeah.
So you can let me know how this is. It's a lot of code, but again,
yeah,
there is room for optimization.
No, I think this is wonderful. I mean, you got the optimal solution in O of n time, and you even cleaned up some of the code afterwards to make some sort of runtime optimization. Yeah, I think this function would work, and I think it handles all the test cases, and I appreciate how you walked me through and allowed me to understand everything and digest it. So I think that's pretty much it for the problem, unless you see any other optimization that you can make.
Yeah, the only other optimization is avoiding this repetition because it could lead to redundant code. So I would actually get rid of all these logics because it would be out here. And I'd avoid popping from an empty stack because of this right here, pushing something in the stack. So I'd at least start with something in the stack. And instead of this else statement over here, I can actually get rid of that if I wanted to and see if I don't have an operator. Because this means if I don't have an operator, last else statement.
Yes.
But I could make an if statement saying if I don't have any of these operators, I can push into my stack. But if I do have an operator, then I will perform an operation. So in each operator, the if statements or elif statements, I would just have this left in all of them.
Okay.
While this is constantly taking the two numbers that I need for each operator or each operation.
Okay.
Yes.
And just a couple more questions. So you would push the first number onto the stack, and then you would begin the for loop. So then would you be accessing the same number twice? How would your function handle that?
That could be possible, and that would be the problem actually with taking this outside of all of the if statements, because if I don't do this, then I will undoubtedly, well, unless it's guaranteed that I might not have, will I have an empty stack?
No, you'll always be given at least like one integer in there, yes.
All right, so I can always start from the next element in the stack,
Yes.
which could be a solution.
Yeah.
And in the case where I'd be given an empty stack, I would not be able to do that. And it looks kind of hard codey. So, I mean, just in of itself, it's a matter of preferring repetition versus something like this that could avoid that repetition.
I see.
So I think it'd be a matter of preference, but there definitely is a way to start from the next element in the vector of strings.
And then also, so you would move this, would this be above or below all these if statements as well?
So if I got rid of that, that would essentially mean, I mean, we can erase this if you'd like.
I think no, this is fine. Yeah.
Okay. So getting rid of that would mean we don't have any of these operators. So I would do something like, I'm going to write it kind of like right here.
All right.
And I'm going to say this is a little else alternative out. Okay, so my last else. So I could have something like if x is not equal to the addition symbol, and x is not equal to subtraction.
Yeah, and then
and
you
so
just
on.
continue. Yes.
Right, so I'll do the dots, so on, and then I would push into my stack, and it would be after this for loop, this for each loop. So I would do stack, push, and then I do string to int and x. And then I would continue, of course, until I find an operator, which it will go to these if statements. So this really just gets rid of that last else statement.
I see. And you're putting it above this if statement then?
Yes.
Okay, I see. All right. Yeah, and then just one thing else. So does this if statement take care of the case where there might not be two integers on the stack?
There might not be two integers on the
Yeah,
stack?
so like, let's say you just have this one on the stack and then you go here and then you push something else. So if, let's say this isn't the case, so you're always going to have these two on the stack, right? Okay.
Well, are you saying that we would only have one number on this stack?
Well, because let's say we put this like after the if statement, right? And we just had this popped out like first, right?
Right.
And then all we have on the stack right now is just this one. But I think if we had this, there might be the case where we're popping and there isn't enough on the stack yet, right? Because we don't know if there's an operator yet.
Right, yeah, I see.
So this would this get rid of that situation?
Well, we could go through a test case if you give me a new vector of strings, and if it doesn't, we can actually optimize it a little bit more. So how about we try that?
All right, yeah. So let's say that we have, let's say 9, 10, and then let's just say modulo, and then we say 5, and then we just have the addition operator.
Okay.
So then how would this newer function handle that?
So let's make some space for that. Or I could actually use a different color, maybe, instead of more space.
Sure, here you go.
Thank you. Okay, so we have 9, 10, modulo, 5,
And then addition.
addition. Okay.
Yeah.
So we start with, let's say we have this if statement first. So we don't have an operator, and we will push 9 in the stack. So my stack, write it here, blue. My stack will have 9. And my stack will also have 10 in there, because I continue. But I've reached the modulo, so I actually go down to the if statement. And before I go down to the if statement, since this is outside of all the if statements, this would actually have like, these two numbers would be popped out since they're at the top of the stack and assigned to their own respective variables, so that when I do reach the modulo, then I can perform the operation. Then push that, since operation is stored in the result, push the result into the stack, and then continue with the next operation.
I see. Okay. Yeah. So I think that clears up anything else that I have about this problem.
Right.
Yeah. I think your solution is great. So
Yeah, I
Thank
think even though it is kind of hefty in that there are a lot of options with like redundant code, style, design, some small optimizations that could affect runtime, I think one of the most important things was being able to rewrite the solution. And even though it's like a small line of code, such as returning result instead of the top of the stack, that could affect runtime. But small things like that versus changing the design of the code could really help with, I think, my position in the job.
all right.
So I also think that I might be able to think from maybe different mindsets when it comes to writing code and thinking about code. So being able to redesign something if you ever wanted me to.
Mm-hmm.
So I'm just putting that out there.
All right. Okay. Yeah. So I think you passed this part of the interview then.
Thank
We're all
you.
done. So congratulations.
Thank you.